And my specialization is the integrations, especially payment integrations, tax calculation, etc. So, but today we are going to talk about the project and team, what we are having here at Sonrisa for this client. And I'm going to talk about the project architecture and the tools and technologies that we use. And we are going to have a demo on microservices communications using Service Bus, Azure Service Bus. And I'm going to talk about how we use service buses. And I think it will be kind of a combination of a case study, how we are doing things, and a demo, a hands-on demo that will show you how communication works between microservices. So let's start. So we have this client in the US. It's a direct sales, as I mentioned. We are working on a product that is for consultants who also sell the products for other people. And we have an e-commerce site for customers. This is the regular e-commerce site with some specialties that will connect consultants and customers as well. So the products are mainly kitchen appliances, and nutritional supplements that you could use in kitchen, and healthy stuff as well. So yeah, these software are around helping consultants to organize party orders. It's, you may have heard of these. You have an event at someone's home, and the organizer will show you the products, and you will probably cook together, and then you can order some of the products that you would like to buy, and that's how the business looks like. So that's the client business. Okay, so we have these teams that are working on this project. So we have two markets. We have the USA, that's the existing market for this company, and Mexico is the new market for us and for the client as well. And we are learning how things are happening in Mexico. So both of the markets have similarities. The base concepts are the same, and the rules are the same, but Mexico and USA have their specialties. They have many differences as well. And yeah, we have the software basically divided into two main parts, and we have a common part, and we have country-specific parts as well. So we have around 100,000 active consultants or so. It's always changing. We have two teams. That was three in the history, in the past. So we have the Consultants Corner team that's focusing on the consultant software that the people are using to organize parties and and manage their business. Also, we have the e-commerce team. We have for the customer-facing software. And these two teams are working closely together because the software has many connections, even because Attent Corner and the e-commerce part is talking to each other. So we have to have a close communication. And sometimes we are, assigning tasks from this team to another one, and we are joining forces to solve issues. Okay, so my team is about consists of 15 people, and the other one is kind of the same, but it's always changing. And usually we are around 30 combined, the two teams. Okay, so we have two tech leads. That one of the tech leads is myself, and we have another one who is a more experienced leading teams. And we have PM / Scrum Master for the two teams, and we have a product owner or business analyst. It's also shared QA team and the DevOps people. They are all shared among the two teams because we have to work together. Okay. We have backend and frontend developers as well and that's how it looks like. So let me talk about the tools and techniques what we use. We have Azure Cloud and many more resources that I'm going to talk about later. We use Scrum, we have sprints, we have the ceremonies, we have a backlog, we have sprints, everything that make up Scrum, and we try to estimate the tasks. We are trying to groom tasks and all the good things that Scrum is about. And we have a little waterfall in the process because we have to tell the client when features are going to go live and released, and that needs to be somehow planned before in order to fulfill the needs from the client side. Okay, we have Git. We are using Bitbucket, and we have multi-repos. I don't know how many repos are we having right now, but I think it's over 20 or 30. We have different or separate repos for each microservice. So they are not mixed up and are therefore separated well. So we are separating on the code level as well, and we are separating on database level as well, but we are going to see that a bit later. And we have common repos or repos for libraries that we use that are also separate ones. Okay, so we use Git flow. We do pull request reviews and all the stuff that you might be familiar with. Okay, we use DevOps. We use the pipelines, artifacts for the private NuGet packages. So common code are built into or packaged into NuGet packages that we are hosting for ourselves in our private repository. Yeah, we use the pipelines to build and deploy and test our software. So that's a handy thing to do the releases in a smooth manner. Yeah, and we use infrastructure as code as well to build up the environment in Azure. So we use Terraform files to create the resources that we need to run on the Azure cloud. I'll show you some Terraform scripts in the demo section. Okay, and we use Jira for handling the project, and we use Confluence to have the documentation. And we use SharePoint as well to share files. We use many clients or many services or platforms to communicate. We use mostly Teams and Zoom for inside and outside communication, the team. And we use Skype and Slack as well. Everything what you have is used because everyone is using different channels. All right, so we have a lot of the integrations. The most important is the client's their direct selling platform. This is called Pravas, and it's shipped by Thatcher Tech, as far as I remember. So Pravas is a popular direct selling platform, and it's heavily customized for this client. So they have custom processes. Okay, this Pravas is using or featuring SOAP and REST endpoints as well, and so we are using these endpoints to communicate with. Okay, we have different payment platforms that we wrap into a NuGet package. So it's so having a common interface for payment-related actions. We try to hide the actual implementation of these platforms, and yeah, we have 2 implementations right now. That is for USA, Braintree, and we have PayPal for Mexico. So I could speak about this for another hour. So I'm going to skip this right now, but it's a kind of a sweet things to me because that's my child. And all right. So we have the tax classifications for USA. It's Avalara, and we have Melissa for address validations. We have a learning platform integration, legacy email platform, pay card stuff as well. So it's a prepaid card platform, and we have many more that I would not cover right now. All right, let's jump in. Okay, let's jump into the architecture. I'm going to use the C4 model to visualize the architecture. So we will use the context and the containers level, and that's going to be enough you to give some overview. Okay, and so the context is the the highest level of architecture, and we are going to see a bit lower level. And if you go further down, you get more and more clear picture and a more how can I say, more detailed level of the architecture. The fourth level is the code level, which we are not using, and it's not not a very common thing to show or have, because the refactorings are happening, code is changing every time, so it would be a nightmare to keep it up to date. So we have around 3 levels that are commonly used, and we are going to cover the first 2. So we see the context level of this direct sales and e-commerce system. So we have 2 or 3 kind of users. We have the normal user and the applicant who become a consultant, and we have the consultant here. And we have 2 systems that are serving these users. And we have the e-commerce system, which is the customer-facing software. And we have the consultants corner, which is for consultants. And both of them are communicating with Prowess. Most of the time is sending content into Prowess. I mean, sending orders that are placed by consultants or users from e-commerce. Okay, that's the first one. And we have the second one, where I just detailed the consultants corner from the previous slide, this one. Sorry for jumping back and forth, but I'd like to make sure that everything is clear. So we have this software architecture for consultants, and let's start with the front end. So the consultant is looking, is opening his browser and sees an Angular client, and this client is making HTTP REST calls to the backend services, which is kind of hidden behind an application gateway and the API management resources that these 2 pieces are doing the load balancing, the routing, the validation, and it just doing the authentication stuff as well. We'll see that later. And we have the app services in the middle here that are going to be targeted by the API management. So we have one endpoint from the outside, and it's going to be routed to the appropriate service behind the scenes by the API management. That's why I'm collected them here. And we have the user management, order management, contact management, and many more that I will not discuss today. And most of them, not each of the services, but many of them are having a backing database, which is a cloud-hosted SQL database. And we have Service Bus and topics right here, and we have many functions as well, and Azure functions, and we have SSRS reportings, and we have a special database and API down here to offload the most of the communication from the client system. That's called Dolly here, and we have a secure database that is a transactional replica of the Prowess system database. So each action is represented here, and we can track the changes, and therefore we can pull and sync changes to our database as well. So this system has an API interface that we can call from our services as well. So that's how it's beneficial to us. So we can ask this system on a higher load than we would do with Prowess. So we can just save some resources for Prowess. Okay, we have blob storages, app configuration, application insights, Key Vault, Azure ADB2C, and cognitive search as well in the system. So it's a pretty complex application, I can tell. Okay, and yeah, so we have the application gateway, which is the load balancer, and it's doing authentication, SSL, TSL termination, application firewall functionalities, auto-scaling, and redirection. And we have the API management. It's a service to abstract backend services, and we can have a single endpoint with its help to represent our system. And it's doing the authentication as well, and it's kind of similar to the application gateway, but as I wrote, it's on steroids. It's a load balancer, reverse proxy, and kind of security is embedded, and you can do monitoring as well. So it has many functions. Maybe the most important that we are using to validate or verify JWT tokens and certificates, and yeah, and we use it to route to the appropriate service. I mean the calls from the Frontend. Okay, we have core settings as well. Yeah. So we have two storage implementations, and one is the Azure SQL database. It's a managed cloud database. It's a single instance per environment right now, and it can be scaled because we could split up the schemas. I mean, we have run schemas for per microservice, so we could split the whole database by schemas, and we could deploy the databases into multiple instances. But if there's a performance need, but we haven't got that to get to the point where it's the database is the performance bottleneck. So that's that was the SQL database, and we have Azure Blob storages as well. We store static contents like images and And we have email templates, PDF documents, etc. And we use Terraform script to deploy these predefined files. So when you build up a system, a new environment, then you could just run your pipelines and run the Terraform script from it, and the files are there. Okay. So we have the app services. We have many of them, and they are REST APIs, and they are now on .NET 6, except for e-commerce, that is .NET Framework 4.8. And we are using the microservice architecture, and everything is in Consultants Corner is adhering to microservices, but e-commerce is a monolithic application, because it relies on Sitefinity, and then we are using the e-commerce module to run the e-commerce shop. So yeah, we use the Sitefinity headless API and a custom client. It's also an Angular client, just to give you an overview of how it looks like. And we have common code, and we build NuGet packages for reusability. We have DTOs, extension methods, etc., in these NuGet packages. So we are, as I probably mentioned, we host these in a NuGet repository on Azure DevOps. Okay, security is JWT token authentication. Yeah, that's also big story that I would not cover here. Well, let's jump into the functions. So it's a serverless solution, very similar to app services, but these are running on demand. We are without needing to host them on a server or managing infrastructure, and they are specialized in a way that they can run scheduled tasks, process message queues, or process data or files. So we are mostly using them to process Azure Service Bus messages or queues, or topics. I'm going to talk about this later. Okay, so the communication between services can be synchronous or asynchronous, and we are using both of them. We use synchronous when we need to wait for the response. Some processes are requiring that you provide a resolution if it was successful or not, or what was the response is important to display on the front end, for example. So we use HTTPS for this. And for the fire and forget style, we use asynchronous communication. That's where the service bus comes into the picture. We deliver messages using Azure Service Bus, and we use topics. And if we don't need exactly waiting for the response, then it's perfect too. And it provides scalability opportunities, because we use topics, so we can read or get the messages from competing consumers. And yeah, we need to strive to minimize synchronous communication, as it's not scalable, and it can break if you have long chains of communications. And yeah, it's this is synchronous communication introduce coupling, so we need to improve independence and independent work of each microservice component. Yeah, that's kind of principle for microservices. It's also a huge topic that I would not go into right now. Okay, so we have the Azure Service Bus, and I'd like to give you a general overview how it what it offers, and later on I will share how we use it. And so Service Bus is a fully managed enterprise message broker. It provides queues and topics, and the difference between queues and topics that queues are kind of point-to-point message communication, and the topics is providing a publish subscribe manner communication. So you can have more consumers or more subscriptions with topics, but I'll show that later. So it's a PaaS offering with all the benefits. So you should not worry about the patching and making it up to date and securing it. So it's all coming out of the box. So this service bus used to decouple applications and services from each other, and it offers load balancing and safely routing and transferring data across application boundaries, and because microservices are not allowed, or it's not good. It's not a good practice to, for example, read and write other microservices database, for example. So you need to pass messages between them to share information. And yeah, it has a high degree of reliability and can introduce or coordinate transactional work. All right. There's a concept of namespaces when we are talking about Azure Service Bus, because the namespace is a container for all messaging components here. And the name should be unique across Azure, I mean globally. And it's kind of a similar to server name. So you refer to a service bus resource by its name of the namespace. So that should be unique. You should be aware of that. All right. There is this queue and topic offering. So as I mentioned, queue is a point-to-point kind of communication, and the topic is much more versatile and usable. So it can have multiple subscriptions, and you send the message once and it will be delivered to all subscriptions and all the receivers can get this message. Only one. Yep, that's how it looks like. So it's a one-to-N relationship between publishers and subscribers. All right. So how we use Azure Service Bus? We have a single service bus per environment, and we have multiple topics, and we have multiple subscriptions as well, or single or multiple. And we have usually one-way message flows, but as far as I remember, we have two-way messages as well, because when an operation finishes, sometimes we need the result. For example, we send in an order to the client system. We will get an ID that was produced by the client system. So we need to save this ID to be able to refer to that, and we need the result of the success or failure as well. So we just have another topic, and the publisher became the subscriber, and vice versa, and we get the message back and forth. Okay, so we have a custom retry algorithm using scheduled delivery, and we use the deadlifting queue, and the deadlifting queue is a queue that going to be used for messages that gonna be delivered, or something happens during processing. So maybe an exception was thrown, and this message that was going to be received that go into the DL queue. Okay. So demo time. We'll be having a demo about theoretical system that is a financial system that is going to be use Azure Service Bus, and it's going to be use a topic with 2 subscriptions. So we are going to have a financial client that is sending messages to the topic. It sends one message, and this message is going to be delivered to the 2 subscriptions simultaneously. So we have this service bus, and we have a topic, and under that topic we have 2 subscriptions. Okay, and we have 2 consumers here. One that is going to be subscribed to the payout subscription. Going back. Okay, and we have an audit service, and that's web API web service that's going to be subscribed to the audit subscription. All right, so the financial client and the payout client is just a simple console applications, and the audit service, as I said, is a web API. All right, I'm going to show you some code. Here's the project. Please let me know if you see the code. But before we go into the code, then I will show you some Terraform scripts. I'm going to be enlarge this a bit. Okay, Okay, I have some resources created by this Terraform script, and I use Visual Studio Code to execute them. Maybe I can detail how it works on a very high level. So you can configure your Visual Studio Code to execute and connect to your execute these scripts and connect to your Azure subscription, your Azure portal. So you can use this to create your resources by pushing the code and initialize the system that is going to be executing your script. And then you need to execute a plan. So you need to plan your Terraform script and then apply. You may destroy it with this same script, as it will just look into the code and destroy that specific resources that was created by this script. So that's how the life cycle goes. You plan and apply and destroy. During plan step, Terraform will determine what resources need to be created or modified or destroyed. That is the first step. And during apply, it applies the changes to the Azure resources. And when you destroy, then it will remove or delete the resources that were detailed here. Okay, so we just create a new resource group here, and we create a service plan for the web application, and do the audit web application, and pass the service plan ID. We have a free tier here, and also we are going to create a blob storage. I will show you later. It's a bit of eye candy that I wanted to share you. So pulling in some popular storage option. Yeah, so we have the blob storage created here, and the container where files can be saved, for example. Okay, we have another one. We have another Terraform script as well here, where I'm going to create the namespace. As I mentioned, it should be named uniquely. That's why we have a random integer here, and it's going to produce a random name for me if I'm lucky. We are going to create the topic here, and two subscriptions, one for the payout service, one for the audit service. This one is going to be subscribed by the payout client, and this one is going to be used by the audit service. Okay, all of them, what you see, are already executed because it takes some time, and I didn't want to wait for that. So I'm not going to share how it looks like, but it's pretty interesting. Okay, so we have the financial client here, the playout client, and the audit service. We have a common project here where I store the connection strings and topic name and and the blob storage connection string and container name as well. In production environment, you would use configuration app config for this, but for the simplicity of sake, I just stored the constants here. Okay. So here's the financial client, and I'm going to detail how this service bus is going to be used. So this client is just sending messages to the topic, and we have the client and we have the sender, and basically line 27 is the important here, and the sender have this send message async call that will send the message actually, and I'm going to use a little console write line read line to read the user input. Basically, I'm going to input the amount, and also that's going to be included in the message. And we include the created at property as well, set to the UTC now date time. All right, so we have this one, and I'm going to start this, but I will not send anything. So enter the amount to pay up. Okay, let's imagine that we have a system where payouts are registered, and some of our colleagues may work with that. And okay, hit okay, like $20. I'm not going to execute this right now because I'm going to detail the client, which is going to be receiving these messages. Okay, so we have the Service Bus client again, and this will not send any messages, but will process messages. And we're going to see these processor created here, and we are assigning the message handler and the error handler methods. And we are going to start listening, and we use the start processing async method for that. Okay, and at the end, we are going to stop processing. Okay, so we're going to see the message handler, which is not doing anything, kind of, just going to be write the body of the message to the console. That's it. Error handler, it's going to write the exception, what if anything arises. Okay, so let's debug. Let's debug this instance. Okay, and just check this one. Okay, I'll go put this these two besides, so we can see what's happening. Okay, so I'm going to execute or send the message with amount 20, and this one, the other one, the client will receive the message with amount 20, hopefully. Okay, so I executed, and it immediately appeared. Yeah, amount 20. Let's play with a bit and enter 21. Okay, let's send another one. a bigger one. Okay, so it just immediately appeared. Okay, let's play a bit more, but I switch off the client and send one or two messages. Okay, three. Oh, sorry. 3, 4. Okay, I sent around 4 messages. Sorry, sorry about the mess here. Okay, I'll close the financial client. So everything was sent, and nothing was listening. No client was listening to the service bus topic. So via the subscription. And let's see what happens when I start the client. Oh, okay. We see the first one, and yeah, that's my mistake. I sent empty amount here, and the second one, again, an empty. Yeah, this is a bit more visible right here, and 3 and 4. Okay, that was received. Let's close. Okay, so you've seen that messages were stored, and when the client or the consumer came alive, it will be delivered. So that's why we are using Service Bus. It stores the messages until the consumer is ready to receive them. So this is a handy stuff, and makes your system reliable. So maybe one of your component is down, then messages will be retained, will not gone forever. So you can be sure that they are going to be received and processed. Okay, we have the audit service here that is going to be receiving also the messages, but I'm going to show how this look like in Azure. So you can see that okay, let's see in a bigger picture. So we delivered around 16 messages. You can see it in the bottom left, and yeah, I'm going to refresh this, and there's 28 in 1 hour. Okay, incoming messages. Yeah, that was the request. Sorry, I'm messing up everything. Okay, so incoming messages were 9 messages that we've seen, and outgoing messages that were 3 and 6. That makes up 9. All right, let's see the topic. We have no queues, and let's see the topics. Here we have 2 subscriptions here. Okay, I think I'm going to be enlarge a bit this one as well. So we have the audit service and payout service here, and we have no messages here because we received all messages, and we have the audit service subscription, which has the 9 messages as well. Okay, let's check which ones are there. Okay, we have this Service Bus Explorer that will show us what's in the queue. So you can pick the messages without receiving them. Okay, pick next messages. Okay, so maybe the message body Okay, we have this first one. It's already here. It's not deleted or not going anywhere. Yeah, we have this big amount. One empty, two, yeah, and the rest. All right. So here how it looks like. Maybe we will have some dead letters if we are lucky as well, because these amounts are going to be received by the service as well. And here's our service. I'm going to refresh that and show you some code before that. We are going to see the service. All right, so we have this simple web API. It's called the messaging controller. I added because we should be able to switch on and off the processing, and this will also show us that the messages are retained. So yeah, and another one to get how the processing is standing. So it is on and off. All right, so let's see the messaging service. It's going to be receiving messages on the audit subscription, and it's using this almost the same code like we've seen for the payout client, but it's a bit more refactored. So we have this client, and we create the processor, and we have the message handler and error handler. So the message handler here is going to process the messages. So we get the body, and we deserialize it as it is a valid JSON object. I mean JSON string, and we are going to create a payout type out of that, or object. Yeah, it's going to have the amount and create that. And this one is in decimal, so the amount should be parsable to decimal. That's probably important. And if payout is not null, then okay, we just craft the blob name, and we'll upload the blob to the blob service, or by the blob service to the blob container. We'll see the blob service later. Okay, so we have this name created, audit, payout, date and time, amount here. Okay, let's see what happens when I switch on this audit service. This is already published. This is already published to Azure, and it's running. Oh, no, I don't want to restart, and when I want to refresh it, nothing happens. All right. Okay, so it's up and running. Here we have the audit service, and we have 2 endpoints. I'm going to try out the get endpoint that is returning a false, so it's switched off. Okay, I'm going to switch it on. It's processing on. All right, it returned 200. That's fine. Let's see if it's really on. So it's, yeah, it returned 200 and true. So it means it should be working right now. And we have this storage account. Yeah, let's see. We have demo SB topic storage. It's a demo storage account. Let's see the storage browser. We Okay, we have blob containers that was prepared by the Terraform script. Okay, so let's see the audit log. Oh, well, here are the messages. Okay, cool. Let's see what's happening here. I'm going to download this file. Actually, all of them are files in this container. You can see that they're all having valid decimal values here in the amount. And we'll see what's happening with the others that are invalid, that will throw errors, and I mean throw parse exceptions, and are going to be placed in the dead letter queue. But let's see how it looks like. Okay, so this one is having the amount 20. All right, let's see what happened with the invalid stuff. Okay, you can see the subscription does not have any messages, so it's the count is 0, but the dead letter queue have two of them. Let's see which ones are there. Okay, this one, the empty amounts. Both of them are the empties. And well, you can choose to resend them probably, or you can probably, yeah, why not? I will select this one, and before I send, I'm going to enter 999, so we can edit it before sending. This is a manual process. Maybe if you have support colleagues, then they can edit this and resend it, or fix data and yeah, let's see what happened. Okay, maybe nothing. Yeah, 999 is here. Sorry. Okay. So because datetime was not edited, it used the original time, but the amount was fixed, is represented here. Okay, just see what happened. Okay, it contains the 999. Cool. And yeah, let's see. Maybe I turn off the processing and some more, or not. I switch it back. Okay. Okay, let's see if it's running. Okay, it's running. And send a message real time. Okay, financial client, start. Let's say 1000. Okay, it was sent. Let's see the container. It just created a new blob file. Okay, that was cool. I hope you enjoyed this small demo, and maybe we can check how blobs are created. Oh, not this one. Blob service. Okay, this is easy. 4 lines of code. You have the blob service client, and it's initialized by the connection string. And yeah, you can get the container. I don't have too much checks, but it's recommended to check for existence. And yeah, you can get the client, blob client. I called it blob, and you can use the upload async method to upload a file. So here's the blob name that we crafted before. So it basically just creates a file. So I haven't talked about blobs before, but blobs are cool to share files via the cloud, and you can refer them later as or with URLs. So if you see this file here in the storage browser, and probably this one, the 1000, you can get the URL. You can copy the URL, and I hope it will be, oh, not, it should be available if you set the proper settings. So it should be available to public as well. So I'm not going to show you, but it's possible. I use it in my other projects as well. Okay, everything was working, but not this. Please, sorry about that. You have to imagine that you can get these data by URL as well. So it's kind of a simple CMS solution. That's how we do in the project to have these data. Okay, let's get back to the presentation, and probably it's here. Okay, so we've seen the financial client sending messages to Azure Service Bus to the topic, and we have 2 subscriptions. One is for the payout, one is for the audit service, and both of them were up and down. And when switched off or switching on, it got the messages. So that was a kind of a very simple implementation and scenario. There are many more that you can do with service bus topics. All right, you can go forward and check Azure Service Bus trigger for Azure functions. That's really how we use messaging. We have many functions, and they are receiving these messages via a trigger. Functions have the concept of triggers, which actually triggers some execution or processing. And one of them is Azure Service Bus trigger, and it's really easy to set them up and receive messages. So yeah, Azure Service Bus have many advanced features. As we see in the tag lettering, they have scheduled delivery that you can use to, for example, deliver messages later when probably a service is down. For example, you check the health of the outside service and or external service. And if you see that the health is monitoring is not going not 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 working, and you can schedule the messages to later delivery. Yeah, you can do filtering as well. We do that in the project. Duplicate detection, alt forwarding, many more. I'll leave it up to you. Okay. Question and answer time. Thank you for having me on this session, and I hope you were enjoying this and found it useful and insightful or whatever.
Yeah, Albert, it's nice. There are a few questions I have put it into the chat window. Can you please look on it?
Yes, just allow me to switch it on. Oh, many more.
I think people are feeling interested.
Oh, cool.
Work on it, and they have many questions.
All right, so for the first one, may I read them and answer them as it goes? Okay, so are you deploying tested source to Azure? Well, in reality, we should have steps in deployments. So we have 3 environments right now. We are adding probably a 4th one. So we have development, we have UAT, and we have production. We have actually 6 because we have the same set for USA and Mexico. Yeah, they are independent environments. So development will contain the master, and automatically this the master, when a merge happens, it will be automatically deployed to development. And it's not ideal. We should do only deployment from a tested and healthy master. But right now we have limited QA quality assurance resources. So we are testing first on development system. And then we go forward with UAT. This is a manual process, manual deployment, and also we deploy the same from the same tag from Git with pipelines to production. That's how we do. So we actually test in development, we test in UAT as well, and the client is testing as well on the UAT. So it's pretty tested when it goes to production. I hope that something answering the question. Right.
Actually,
okay.
Actually, the production who is playing the role or deploying the production deployment after UAT?
Who is planning? Or
who is deploying the final
who is
deployment?
Deploying? Yeah, our team is deploying.
After UAT?
After the UAT, yes.
Right.
It's a common agreement. When the client is ready to say it's okay, then we can do the production deployment.
Is it?
But it's also
actually, yeah. I want to know that who is deploying, QA team or the deployment engineers are doing this?
We don't have actually deployment engineers. Our QA team is qualified to deploy from a certain tag or certain repository. So it's a kind of an automated process, but you have to trigger manually, actually.
Right.
Okay.
That is happened by CI/CD pipeline.
Yes.
Yes.
With
Okay.
Azure DevOps.
You're using Azure DevOps, and there's just that is triggered by the QA team. Actually, in our case, implementation team is there, and who are responsible for deploying these stuffs. Thank you very much, Albert.
All right. Let's move on to the next one. If then, how the unit testing and integration testing conducted using any test automation tools? Yeah, we have many unit tests and also integration tests as well, and they are run by the DevOps pipelines after each merge. So when someone's merging a feature branch into master branch, then these tests are run, and we see it on the PR. So if a build fails on whatever stage, it will be shown. So we are not allowing failing feature branch into the master. So this is how it is conducted. Yeah, and we are using Azure DevOps.
Is there any automation tools are used? Are you using any automation tools for conducting unit testing?
We have XUnit framework that is used.
Okay.
That's the code level, and we have the pipelines that executing the unit tests themselves. Okay. I hope that's clear answer. Okay. Which deployment are used by QC tester form testing? Form testing? You mean front-end test? Or which deployment are used by QC? I think I have answered it before. As,
right, you have answered it earlier.
We have dev and UAT as well. So most of the testings are going to be happening in development. Actually, I haven't mentioned that we don't use containers or Kubernetes or anything else on this project because it would introduce complexity, or well, it's a historical decision that I was not involved in. But if we would use containerized environment, we could test on environments that are built up as needed. And for example, we could build up a whole environment for a feature branch. But but we don't have that. So we need to deploy it to a certain existing environment. That's the bottleneck, I would say. Okay, are you using Wizard for configuring CI/CD pipeline or using YAML script? We are using YAML, and the Terraform as well. So yeah, we have these pipelines in a separate repo. Or we have a pipelines repo where we are storing YAML files and YAML templates for different repositories as well. It's I'm not professional in this, but that's how it looks like in high level. All right, are you using Kubernetes? No, we are not using Kubernetes. And it's it would be much complex and much more simple from the testing side, or preparing a whole environment. That would be probably better. But we are living with this. Okay, how you are conducting performance testing if you deploy directly to Azure. Performance testing if you deploy it. Well, we run many performance testing, and we are using, I forgot the name, JMeter. And we have
JMeter, right?
JMeter.
JMeter is normally used for performance testing.
Yes, we have many scripts. I mean, a few scripts that cover the most important scenarios, and we run them occasionally on certain systems, not all. And it's not automated; it's manual. Performance testing. Yeah, we have Azure. What's the name of it? I don't know. We had using to visualize JMeter results.
JMeter.
Yeah, JMeter. We have JMeter, and you can run JMeter scripts from Azure. But I don't have the name of the resource. But you can search for it. I'm not going to search right now, but I was involved in it, but for a conceptual thinking, but not in the actual execution. All right. Yeah, fifth question. Are you using Bitbucket or Bitbucket? Maybe. Why you need to do using blob storage?
I think you have answered this question earlier.
Okay, so
before the end of the your session, your demo.
Yeah. Bitbucket is kind of a repository. It's a private. It's a private one. It's a private thing. So we don't want to share anything inside the repository because it's the source code, and we are not going to share any files from there or content. That's why we use blob storage, which is publicly shared, and you can have URLs to each content or file in the blob storage, so it can be shared pretty safely or easily. So that's why we are using blob storage. Okay. How are you doing integration testing, say with PayPal integration? Wow, that's a good question. That's my part, so I can talk about a lot. Basically, we have integration tests, like, let's say, kind of unit tests, but you are setting up a real client. I mean, a real SDK client in the tests, and you run real transactions or real payment actions with the integration. And we have sandbox accounts. You can create sandbox accounts with PayPal at any time. It's free, and you can check your code or integration with sandbox. And when you are moving on to the production, you can hope it will behave the same, but it's sometimes it's not very, very close to the production, especially when you are dealing with credit cards or debit or credit cards. It's very interesting, and you can learn a lot from that. So I really like doing the payment integrations, and I think it's the heart. It's one of the heart of the projects. Let me say this, because money is money. That's probably the most important thing, apart from the the business. And when something is, your card is charged and you don't get what you promised, what the company promised, then you get angry, right? So yeah, you have to be careful. So that's that. You cannot really test everything with PayPal. So end-to-end testing is not possible because you have to approve the order or the checkout order that you created. So you have to approve it in the browser, and you cannot do that from behind the scenes from the server applications. So when you hit, I haven't gone into details, but we use these yellow button and black button PayPal embeddable front end thing. And when you hit the yellow button, that's when you approve the checkout, and you can add the card details as well. So it's a manual thing that you cannot automate or integrate test. But with Braintree, it's basically it's possible. So you can end-to-end test Braintree, but not PayPal. That's a big difference. All right. Many more. Integration testing, sixth question. How can you implement message retry handling with Azure Service Bus? Oh man, that's not really my part, but we wrote a question, a custom code, and we checked if the message was not delivered in time or something like that. I don't want to lie to you, to be honest. I'm not sure about the details, but if we detect that message is not okay, I mean the delivery is not okay, or the client service is down, then we schedule the messages later. And yeah, probably I'm not the best person in the team to answer that. So I would skip that.
So far, I know that there is an option, there is a policy configuration option is there in Azure for Service Bus in this context. So you can set up some policy configuration where you can get the what will happen if the message retrieval handling is required.
Yeah, probably yes.
Yes. Maybe.
I haven't
Yeah,
gone into the very details. Thank you for helping me out. Yeah, service bus is a huge topic, so I think you can do many things with it. So is it possible to debug Azure Service Bus locally? If yes, then how? Well, we can debug it, probably, but not the service bus itself. You can debug the sending part and the receiving part. I think what happens in the middle is the part of or the work of the service bus internally. So you cannot debug the service bus internally, I think. But you don't have to, basically, because it's a service. Then you have to rely if it works well.
Actually, Albert, I want to add something if you allow me.
Yeah, sure.
Basically, so for my understanding that it is possible when yes, it is possible to debug Azure Service Bus locally if you can do this by setting your breakpoint in your code and then attach the debugger. I think that will be possible.
Yeah, I can maybe show it if you want. Which services are? Okay, here's the financial client, payout client. Let's see what happens. Okay, here's the payout client, which is getting the services. I mean the messages from the service bus. And let's, okay, 2002. Yeah, debugger hits the breakpoint, and let's see what we've got. Here's the message. Here's the body. Right here. You see it. And yeah, here's the body. Actually, let's.
Yeah, you can debug by this way actually.
Yeah. So here's the body. We've got this. So you can put your debug breakpoint in the message handler. And maybe I can show you what happens when you hit. Oh, it's not going to be it, but maybe. Let's see an exception. Not this. Yeah, probably. Yeah, and we'll see if this error handler. Yeah, it's going to hit the error handler. And yeah, here's the exception. System exception was thrown. That's how you use. Yeah, but
this is the way actually.
Yeah, but this all on the receiver side, right? Okay.
Right.
Yeah. Okay. So that's how you do that.
Yeah. Thank you, Albert, for giving us a demo.
All right. Yeah, we have another one. How is rebalancing performed in Azure Service Bus? Well, good question. I don't really know how this is happening. Rebalancing. If you can just elaborate what is the rebalancing? I haven't heard that term in connection with Azure Service Bus. I don't know what you mean, but it is not rebalancing the messages between subscriptions and topics because they are differently. Right. Yeah, so the messages are sent to a topic, and then to a subscription will stay there. You have to receive them actually, like when you pop an object from a stack or queue, from a C# queue or stack. So you can peek it, just look into the box and see what's there, or pop it actually. That's how it looks. And Azure Service Bus will not put messages here and there. Maybe from that letter queue from the topic. I think we are done. We are done here.
Thank you very much, Albert, for your nice demo and extremely helpful for the people who are going to work on it, and encouraging also actually. And you have fantastically demonstrated the ground and the whole things of your application and the tools and technologies you are using in your application. And I think that also helpful who wants to develop who actually wants to plan for Azure based some application deployment that will be helpful for them also. And you have some demonstration is there, and demo it will helpful to hands-on actually. Very nice, actually fantastic.
Maybe I can share the code
Actually, fantastic. Actually, so far I was with you, and I have learned many more things from you. And I think the community people who are also with us, and they also be um, rich in have reached their knowledge, and very good actually in a word.
Cool. Thank you. Thank you. I hope you
Thank you,
enjoyed.
Albert.
And happy coding, happy Azure cloud development, and maybe you got you got some insight how things are working here at Sonrisa on this project. Every project is different, but this one is presented to you, and I hope you get some good good points, and you can take them with you, and maybe you can use these things in your project or
Right.
or wherever you want. Okay.
Thank you very much, Albert. Hopefully, we will get many more new topics and new ideas, and hopefully you will participate in coming months in 2023,
Yeah,
and it
looking
will be
forward.
helpful for it will be helpful for the technical audience for getting up to skill their knowledge level. Uh, so now I wanna say towards the community that we have ended the today's event, and I hope it is a fantastic session, and we are very much thankful to Albert to demonstrate us the whole things, application deployment and the Azure Service Bus, and there are many more questions coming out from the community, and these questions answer will be helpful also for you. And thank you for joining with us, and hopefully in next month's 18th of the February we will gonna arrange a new new event, and until that we are hopefully you will be happy, and thank you very much. So we are going to shut down today's event. Thank you everyone for
Okay.
joining.
Thank you. Bye bye.
বাই বাই, আল্লাহ হাফেজ সবাইকে। আজকের আমাদের ইভেন্টটা আজকে এখানে শেষ হচ্ছে, এবং আমরা সামনে 18 তারিখে ফেব্রুয়ারিতে নতুন একটা ইভেন্ট করব, এবং সেই ইভেন্টটা আমরা অ্যারেঞ্জ করব ইনশাল্লাহ যে ডেটা প্ল্যাটফর্মের উপরে। অ্যান্ড আমাদের সামনের ইভেন্টে আপনাদের সবাইকে জয়েন করার জন্য আন্তরিকভাবে অগ্রিম শুভেচ্ছা, অ্যান্ড থ্যাংক ইউ ভেরি মাচ ফর টুডে। আল্লাহ হাফেজ।